Hey, good evening, guys. So my next project, while I'm waiting and doing experiments in between, I'm going to build the Clement Figuera commutator. I probably said his name wrong, but it's in the description. I'll try to link the patent or some information about it. But basically, it's a commutator with 16 contacts. Now, only 8 of them have a lead off of it. Okay, now 1 connects to 16 with a wire, 2 connects to 15 with a wire, 3 connects to 14, and these two commutator contacts are connected. Then you have 8 wires coming off. So there's 16 contacts. Now only one brush moves. In my case, it's going to be 2, which connects 1 wire at a time. 1 wire, 1 wire. When it hits this one, it connects number 8 again. When it hits this one, it connects number 7 again. 6, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1, 1, 2, 3, and it makes that kind of motion. Okay? So, I'm not going to go over the whole dynamics of the machine. You could read about it if you're interested. But I'm going to make this commutator next, which I'm already printing out. You'll probably hear it in the background. So down here is what I have started. These are pre-1981 pennies that are mostly copper. I just silver tipped them on the tail side. So when I put them in my 3D printed holder, they'll be easy to solder without melting the holder. I just want to touch it to get the wires on, but I want to get it all in place first, so I silver tip those. Then I have one big steel washer, so I'll show you my design that I'm going to do. This is printing this sucker. Okay, so the pennies sit into these channels here, and the wires go right through to the underneath, and then they connect from the underneath to each other. So you have 16 pennies with wires connecting them. Okay, that big washer, this washer here, this sucker, is gonna go right in the middle. Okay, now all these holes are for mounting. Okay, that's just to hold it, because this isn't gonna spin. This just stays still with all the wires connecting to it. Okay, then I'm gonna get something, I'm thinking like a computer fan or a small motor of the likes to go underneath this, and the shaft comes out the middle. Okay, one brush is going to go right to the center and always make contact with the center, and this one is going to be supplied by the hot lead of the battery or the supply, so the brush will always be hot. Then that brush will have a wire that connects to the outer brush, and when this turns, it will transfer this positive potential here to 1 penny at a time as the brush goes over these pennies. Okay, so that motor just spins and it activates 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1, 1, 2, 3, 4, and repeating as it spins. So again, I'm going to have to design the motor mount and the arm that comes out and the brush holders for 2 brushes, and then turn it on, and this thing should do what I want it to do. And this is part of the Clement Figuera generator. Is it going to work? I don't know, but apparently there's information out there that Nikola Tesla mentioned him a couple of times and his invention. I don't know if he agreed with it or not, but there's a big claim out there, and I have seen very few people attempt to make the actual commutator that Clemente maybe himself designed. So again, this is his design in his drawings of how it works. The positive brush has to hit each one of these contacts and go around, then this goes out. So I'll be updating once I get this commutator working. I think it'll be an interesting build, and I enjoy doing it, so it's not like waste of time or anything. So excellent.